We'll have a look at example 2. We're told our length between perpendiculars is 140 and our vessel has to pass under a bridge with a clearance of 20 centimetres or 0.2 of a metre above each mast, and the height of the bridge above the water is 20.2 metres. We're told our present drafts, forward 6.04 and aft 6.8. And we have a foremast truck and a mainmast truck, and with the aid of the particulars we need to calculate the minimum amount of ballast to load and the drafts required forward and aft to clear the bridge. So in other words, with our truck, mainmast truck and a foremast truck, we're going to be too high out of the water to enable us to pass under the bridge with a clearance of 0.2 of a metre. So we're going to have to load ballast to lower the vessel in the water so that she can actually go under the bridge. With these problems, when we're looking to work out values of drafts forward and aft to have ultimately, we don't have anything to do with the forward and aft draft, the present drafts at the moment. They don't present part of the problem at this moment. So I've done a sketch here, and we're told, I'll just try and set it out here with the information that we've been given. I've drawn the bridge, 0.2 metres clearance, and we're told our length between perpendiculars is 140 metres. Our aft mast is 27.3 metres from the keel, and our forward mast is 26.5 from the keel. From the after perpendicular, we're told the distance of the foremast truck is 100 metres forward of the after perpendicular, and the mainmast truck is 30 metres forward of the after perpendicular. So we need to work out what the drafts are at the foremast, or what they have to be at the foremast to allow us to clear the bridge. So the draft at the foremast is going to be the height of the bridge above water, which is 20.2. That's what we're told in the problem, that the height is 20.2, and we're going to subtract the 26.5, which is we're told the distance from the keel to the top of the mast. We need 0.2 clearance, so we add that to the 26.5. So in other words, we're looking for 26.7. Take it from the 20.2, which is the clearance we've got, and it means if we have a draft of 6.5 at the foremast, we can actually go underneath the bridge. The same exercise for the mainmast. 20.2 again is the height we require. Our mast, the mainmast, is 27.3. We need the 0.2. So 20.2 minus the value here gives us a draft at the mainmast of 7.3. So we know what the drafts have to be at the masts, but the problem now is how do we work out what the draft should be forward and aft? Because we need those to calculate the true mean draft and therefore the displacement required. So when we look at these three triangles here, they're all similar triangles, the same angle. So 0.8 is the difference between the drafts, which we've got 6.5 and 7.3. So the difference between the 6.5 and 7.3 is the 0.8 here. We know the distance between the masts because we're told the aft mast from the after perpendicular is 30 metres, and aft to the mainmast is 100. So 30 minus 100 lets us know that's 70 metres. So 0.8, 70. We're looking for this value, y, and we know the value from there is 30. And similarly forward, we're looking for this value, x, and we know from the forepeak to the mainmast, we're told, is 40 metres, or we can work that out because it's 100 metres to this position, total of 140, means we've got 40 there. So that means we can actually write here the positions of everything. So we've got the aft peak, mainmast, foremast, forepeak. Distance from the after perpendicular, well, it's 0, 30, 100 and 140. The difference between them, 0 to 30 is 30, 30 to 100 is 70, and 100 to 140 is the 40. So that's where we get those values from. The drafts that we worked out, 6.5 and 7.3, the difference is 0.8. So all these triangles here are similar. 0.8 over 70 equals x over 40 equals y over 30. So let's have a look how we would solve the problem with that. So x over 40, x represents the forward difference, equals 0.8 over 70. So we would use the middle values because we know both sides. So we can use that one combined with that and this one combined with that to solve the x and y. So the forward difference x we're looking for over 40 is 0.8 over 70, cross multiply, and we find the forward difference is 0.457. Do the same aft. The y value over 30 is equal to 0.8 over 70, therefore the aft difference is going to be 0.343. We know at the main mass we've got 6.5 and 7.3 aft. We put the differences in and we would subtract the forward amount, obviously, subtract that forward and obviously add the after amount. So it tells us that our final drafts have to be 6.043 forward and 7.643 aft at the perpendiculars. So now because we knew the values of the draft required at the main mast, mathematically we can work out the value to add and subtract to our two drafts to get our drafts at the perpendiculars. Now our present drafts, we're told, is 6.04 and 6.8. So to solve the problem now, we simply work out the true mean draft out of the final drafts, the true mean draft out of the present drafts, subtract, go into the tables and get the displacements and subtract one from the other, and that will solve the problem. And we can see here on the example that we've written here to find the initial and final true mean drafts, pelk to discharge. Let's find the initial condition, final condition. Okay, in this problem we use the TPC because we were obviously given that in the problem, so we'd get the difference between the two drafts here, the rise, and we'd multiply by the TPC. You could also have got the true mean drafts for both, gone into the hydrostatic particulars, read off the displacements for both and subtracted one from the other, and that will just solve the problem. In fact, I'm just looking at the different page there. We've got looking at page 85. Sorry, let's just forget that little bit I told you then. Page 85. Here we have the drafts that we found out, 6.043, 7.643. To find the final true mean draft and displacement, as I say, we work out our true mean draft, go into the tables, and we found it was 14,278. The previous exercise used a TPC, but I'd rather we looked at these involving the hydrostatics. Obviously we get our initial true mean draft and displacement and we subtract one from the other, so initially we're at 13,272, final displacement 14,278, subtract one from the other, and that's the cargo that we would load.